Hi, my name is Leah Ning, and I chose to do my AP Stats Data for Good project on volcanic regions and thyroid cancer incidence. Thyroid cancer is the most common type of endocrine tumor, and the most common type of thyroid cancer is papillary thyroid cancer, which occupies over 80% of all cases of thyroid cancer. Papillary thyroid cancer is actually the most common cancer for women younger than 25 years old, but usually it can be easily cured if treated early enough. According to the American Cancer Society, 97% of people diagnosed with the cancer are still alive 5 years later. However, thyroid cancer incidences are increasing steadily all over the world, possibly because of more accurate detection. But what actually causes thyroid cancer is very unclear. Scientists believe this cancer to be a result of mainly genetics and environmental factors, but they don't know what specific types of environment exposures could contribute to the cancer. Here is a picture of the thyroid. It's the pink colored gland at the neck's base, and typically for patients with thyroid cancer, the front of their necks are extremely swollen, as you can see in this photo. So the volcano I analyzed was Sicily's Mount Etna, which resides in a province of Italy called Catania. At nearly 11,000 feet, Mount Etna has massive continuous eruptions. From 2002 to 2004, it had an explosive eruption that showed that Etna is a potentially explosive volcano, and it has been historically. For more than 500 million people worldwide, volcanoes are a real threat, so it's extremely important to determine if volcanic environments truly favor tumorigenesis or not. So my statistical question is, does living near a volcano influence chances of developing thyroid cancer? To test this question, I decided to use a chi-squared association test. For my data, I went to the Journal of the National Cancer Institute, and I used all incident thyroid cancers for females and males in Sicily from January 1st, 2002 to December 31st, 2004, as a sample of all the years Mount Etna has been active. I assumed the sample to be representative of all those years. Over here is a table of raw data that I got from the Journal of the National Cancer Institute, and it shows the exact number of female and male residents that develop thyroid cancer. Since thyroid cancer generally affects women more than men, it's not surprising that we see a significant difference in thyroid cancer incidence for females and males, regardless of the environment characteristic over here in this graph. To reduce the potential confounding that gender would cause, I decided to use blocking and perform statistical analyses for both genders separately. So for my chi-squared association test for females, my null hypothesis is there is no association between living near a volcano or not and thyroid cancer incidence for females in Sicily. My alternative hypothesis is there is an association. For the test for males, the null and alternative hypotheses are the same, but obviously instead of females, I used males in Sicily. So over here is my chi-squared association test for females, and this is my table of counts. In bold are my observed counts, and in parentheses underneath are all my expected counts. So as you can see, all expected counts in this table are greater than 5, and I assume that the sample is random and representative of all the years Mount Etna has been active. And even though the total sample size is over 2 million, which is very large, it is still less than 10% of all females in Sicily throughout all the years Mount Etna has been active, so it's reasonable to assume independence in sampling. So here's my table of counts for the diagnosis of males based on environmental conditions. As you can see, again, all the counts are greater than 5, but the counts in the table are smaller than the values for females because males are less likely to develop thyroid cancer than females. Again, all the assumptions are the same as for the females. So for my chi-squared association test for females, chi-squared equals approximately 254.2584 with degrees of freedom of 1, and the corresponding p-value is approximately 0. For males, chi-squared is approximately 45.2335 with degrees of freedom of 1 and corresponding p-value again of approximately 0. So since both p-values are less than the significance level of 0.05, for both genders, we reject the null hypothesis. Based on the data collected, we have sufficient evidence to support the claim that there is an association between living near a volcano or not and thyroid cancer incidence for both females and males in Sicily. To verify if thyroid cancer incidence rates are greater in volcanic regions than non-volcanic, I used a 2-proportion z-test to answer this question. For my 2-proportion z-test for females, I defined P1 as the true proportion of females who live in the volcanic environment of Catania who develop thyroid cancer, and I let P2 equal the true proportion of females who live in the non-volcanic environment, which is all of Sicily excluding Catania, who develop thyroid cancer. My null hypothesis is P1 minus P2 equals 0. My alternative is P1 is greater than P2. For males, the parameters P3 and P4 are the exact same as P1 and P2 respectively, except instead of females, it is males. I decided to use a significance level of 0.05. So here are my assumptions for females. Both samples are less than 10% of both respective populations, so it is reasonable to assume independence in sampling. We also assume simple random sampling and that the 2 samples are independently selected. Here are my calculations that I did for this test, and as you can see, all 4 calculations are greater than 10. So that means that the central limit theorem applies and the sampling distributions are approximately normal. So the same thing for males. Both sample sizes are less than 10% of population, and the calculations are done here, and they're all greater than 10, so central limit theorem applies, and the sampling distributions are approximately normal. So for females, Z equals approximately 15.9455 with a corresponding p-value of approximately 0. For males, Z is approximately 6.7256 with p-value again of approximately 0. Since both p-values are less than the significance level of 0.05, again, for both genders we reject the null hypothesis. Based on the data collected, we have sufficient evidence to support the claim that the true proportion of people living in volcanic environments who develop thyroid cancer is higher than the true proportion of those who don't live near volcanoes. So based on all of our data, we do have convincing statistical evidence that Sicily's volcanic environment could be a risk factor for papillary thyroid cancer. The striking increase in papillary thyroid cancer incidence associated with the Mount Etna volcanic environment suggests that residents of other volcanic regions could also be at increased risk for thyroid cancer, and possibly other cancers too. This could help researchers better understand the one of many unknown reasons why thyroid cancer incidence could be increasing. More awareness would lead to more testing for residents in volcanic regions, which would ultimately lead to earlier and more effective treatment for this cancer. So I tried to find random sample data online for Sicily, but I could only find full population data for certain years. And until I realized that I could, after a lot of thinking, I realized that I could use that data as a sample of all the years Mount Etna has been active. Overall, I would have liked to analyze more volcanic regions, such as the Pacific Ring of Fire, where the majority of Earth's volcanoes lie. So here are my works cited, including photo links and articles that I used. Thank you for listening.